Hello class, this is lesson 3-4 about the intercepts of graphs. So I have the graph of a line here, and this point that I'm highlighting is called the x-intercept. And that's because it is where my graph is crossing the x-axis. And the coordinate of this point is always going to look like some number, comma, 0. Okay? This other point that I'm highlighting right here is the y-intercept. It is the point where your graph is crossing the y-axis, and its coordinate is always going to be 0, comma, some number. Now, I'm going to highlight a certain section of this graph, and this right here is representing where this graph or this function is positive. Okay, so we're going to write that down. Likewise, the other half of this graph that I'm going to highlight here is where the graph is negative, or where this function is negative. Okay? So, we're going to see what this looks like in other graphs, and I want us to find the x-intercept, the y-intercept, when the function is positive, and when this function is negative. So let's see, the x-intercept is located right there at 3, 0. The y-intercept is up above at 0, 6. So those are pretty clear to see. Now I'm going to highlight for you the positive section of this function. And if I were going to describe it in words, I would describe the x values. So it is positive when all of those x values are less than 3. Now, I'm going to highlight the negative portion, which is below the x-axis, and I would say that this happens when all of the x values are greater than 3. So these are just additional ways for you to interpret a graph. Let's do it again. This time I have a parabola, and the x-intercept, it looks like, is right there at -4, 0. But in a parabola, there is a second point that is crossing the x-axis at 3, 0. So this has two x-intercepts. The y-intercept is down below at 0, -6. And now when I'm describing when the function is positive, it occurs in two different parts of the parabola. So it occurs when the x values are less than -4, but also when the x values are greater than +3. You see that? Now, this time let's examine when this function is negative, when it's below the x-axis. And it actually is all of the x values in between two different points. So when x is between -4 and +3. Another way that you could write this is a compound inequality, so -4 is less than x, which is less than 3. So you might see that. All right, this time I have a real-life situation, and it says, what can you observe from this graph? So just looking at the premise of this graph, it's describing the height of a ball over time. This x-intercept down at the bottom is located at 6, and I can see that that is representing time, so that means that the ball at 6 seconds is at a height of 0, which means that that's when it's back on the ground, okay? So I can say that the ball will hit the ground after 6 seconds. Now, like we've been doing, let's look at the y-intercept. It is located at +1, which is our height. So that means that at the very beginning, the ball is at 1 foot in the air. Okay, so probably the person is holding it at 1 foot above the ground. So now let's look at what parts of this graph are positive. Okay, so which parts are above the x-axis. And that's going to tell us where this ball is in the air. So I could say that the function is in the air, meaning that it's positive, between 0 and 6 seconds. But after that, if it was going to go negative, that would mean that it would be below ground, right? So the function in this case is never going to be negative. So hopefully that makes sense. Let's look at another problem that has a table. You have a Starbucks gift card for $150, Each day you spend $3.75 on your drink. The table is a log of all of your spending. Find the intercepts and describe their meaning. So this should be pretty straightforward. I don't need to graph this. I can just look at the table, and where I have a number in my x value, but a 0 for the y value, that's the x-intercept. So at 40, 0, I will find my x-intercept, and this means that after 40 days, the balance of my gift card is going to be $0. So that just means that we spent all of our money. Likewise, the y-intercept is where the x value is 0. So at 0, 150, I find my y-intercept. And this is telling me that at the start, when there have been 0 days that have passed, your gift card has $150 on it. And that's it for interpreting this table. So now in our final two examples, we're asked to solve a function by graphing. We're starting out with something that looks like a simple equation, and we have solved equations already this year. But instead, we are going to graph this. What we're looking for is where the graph of this equation crosses the x-axis, because the x-intercept is actually our solution. Just as when you solve the equation and you're looking for x, that gives you the solution for your equation. So let me run you down the steps. First, what we want to do is we want to move everything to one side. Okay, and so we're just going to do this very simply by moving that 1 over to the left-hand side. So I'm going to subtract 1 on both sides of my equation. I'm left with negative 2x plus 6 is equal to 0. So now what I want to do is I'm going to replace the 0 with just the name of our function. We'll call it f of x. So I'm just going to rewrite this real fast, and I'm going to say f of x is now equal to negative 2x plus 6. So that's the name of my function. Now what we're going to do is we're going to make a table, and like you have probably done in the past, we're going to pick some points, plug them into our function, and then I can graph those points. So for my x values, I can always pick them. I'm going to pick the easiest numbers, 0, 1, and 2. When I plug in 0, that's negative 2 times 0, which is 0, plus 6 is positive 6. When I plug in 1, that's negative 2 times 1, which is negative 2, plus 6 is positive 4. And then when I plug in positive 2, let's see, negative 2 times 2 is negative 4, and negative 4 plus 6 is positive 2. All right, so now I have 3 points. Let's go ahead and plot them on my graph. 0 all the way up to 6, 1 all the way up to 4, and then 2 all the way up to 2. And so I connect them with a ruler, and there we go, there's my line. So I can see the y-intercept and the x-intercept, but again, remember, I'm only interested in the x-intercept. And so here, the x-intercept is actually located at positive 3. And so that means that the solution for this function is at positive 3. And that's it. All right, so we're going to go ahead and do one final problem. This time it says 4x plus 3 is equal to 4x minus 2. Again, I want to move everything over to the left-hand side, so I'm going to subtract 4x on both sides, and then I'm going to add 2 to both sides, and it looks like a lot of things cancel out. All I'm left with is 5 is equal to 0, which you might think would be no solution. So think about that for a moment, but we're still going to replace the 0 with our f of x. So the function is equal to 5. Like we did before, let's go ahead and create a table, and let's choose some points to plug in for our x values. I'm going to pick just some random points. Negative 3, that is still going to equal 5. If I pick 0, that is also 5. If I pick 2, that is also 5. So every number that you pick for your x value, the y value is going to be 5. And when I connect all of those points, it is giving me a horizontal line. So this is not even crossing the x-axis, which means that there is no solution for this function, which is probably what you were thinking when you saw that 5 was equal to 0, because that is not true. So, I hope that this lesson made sense to you. Please let me know if you have any questions when you come into class.